last 2 days was talking about a parallelogram, and again now, we're building off of that. So everything that we talked about as a parallelogram is going to occur today too. So somebody say one of the characteristics that makes a quadrilateral into a parallelogram. Which sides? Opposite sides are congruent. What else? Opposite sides. Both sets of opposite sides are parallel.
If diagonals bisect each other.
The diagonals bisect each other.
Opposite angles are congruent.
Opposite angles are congruent.
Consecutive sides are supplementary.
Consecutive angles are supplementary. Right? Those would be the 5 things that we kind of talked about. So that made a quadrilateral into a parallelogram. Okay? So now we're going to talk about a rectangle. And the first thing that we say about a rectangle is that it is quadrilateral, right? Nobody can argue that. All we're saying when we say it's a quadrilateral is what? It's 4-sided. And everybody knows a rectangle is. Okay? So then we're going to say it's a parallelogram. So all of the things that we just discussed has to be true again today. But what's special about a rectangle? So a parallelogram with 4 right angles. Is that correct? So then we go into what's special about a rectangle. Well, one of the special things that's this, right? But then we get into some new theorems. So where are we at? 13 already. So 613 just simply says, if A, again I'm going to abbreviate so I don't have to write it, parallelogram, is a rectangle, the diagonals are congruent. So not only what Mr. Rulin said, that the diagonals did what?
Bisect.
They bisect each other. Now they are definitely congruent to each other. So let's draw this out. Draw a rectangle. What has to be true?
2 sides are like
They have to be parallel. Do I have to draw all 4 boxes? No, because why? Because the opposite angles, like Aaron said, and then Shetler said about the consecutive, right? So that makes 1, then all 4, right? And so now we're going to draw this diagonal. And then I draw this other diagonal. And if this is truly the same thing, or if it is truly a rectangle, then those 2 lines that we just drew are exactly the same. That's what this theorem is saying. So what actually happens? Well, now, look at this triangle right here. And this triangle right here.
Those 2 are congruent.
They're congruent, and also we could call them what? What kind of triangles? What kind of triangles?
Isosceles.
So this x and this x would be one set of isosceles triangles. What's that mean again?
2 sides are
Okay.
congruent.
2 sides, so my dash side and dash side are and the opposite angles, like somebody said, I think. And then how about y and y?
Congruent.
Also the same thing, but obviously what? Different than the other 2 sets, bigger or whatever. But it's still isosceles, right?
So
Okay.
that's the second set.
So y and y would be a second set, right? So this is an isosceles, but so are these, and there's 2 different sets. And then when we get to a square, hopefully you can already start to see what's going to be true about all those triangles. They're going to be the same, right? Okay. Everybody all right with that?
right, I think they'll still bisect each other.
And they still bisect each other. So that's why they're isosceles triangles, right? So if this is congruent to this, we could really come back and put slashes all through there, right? Because each one of those have to be congruent to each other now. Even though they're not going to form the exact same triangle all the way around. Make sense? Because again, the top has to be congruent to the bottom and the right has to be congruent to the left. Okay? If you actually want to prove this, you could go through this big old ginormous proof. So Gabriel will do that for us later. Leads us to theorem 614. Which says, again, same thing. This would be what we kind of did yesterday from the first day. So 614 to 613, this would kind of be the converse of. And what's the converse mean again? Kind of the opposite, or we're flipping it around. So this is saying, hey, this is a rectangle. So if it is a rectangle, the diagonals are congruent. This one over here is going to say, if the diagonals are congruent, so if the diagonals of a parallelogram, so we're saying any parallelogram, as long as we can draw the diagonals and prove that they are, how are they going to prove it to us?
Slashes.
Slashes, or just simply telling you the numbers, right? This is 7 and this is 7. That proves it too. So if the diagonals of a parallelogram are congruent, then what?
It's a rectangle.
The parallelogram is a rectangle. So do you see the difference? 613 is saying, hey, this is a rectangle, so I know the diagonals are congruent. This one over here says, if they're showing me the diagonals and if they're congruent, if they only bisect each other, then we just have a what? A parallelogram. But if they show that they bisect and they're congruent, then we have a rectangle.
Well, if they're bisecting, we hope they both be congruent.
Not necessarily. They don't have to be congruent to each other, right? When we take that parallelogram and squish it. Right.
If that's just bisecting one of them, and the other one's not bisecting the
Yes. They're still going to bisect each other.
other. But, yeah.
Okay. So from here then we go through and there's going to be a section about graphing them. And how would I know that if I plotted this right here on my coordinate plane, how do I know that this side right here and this side right here, especially if it's tilted and it's not exactly on my lines, how do I know that this line right here and this, or segments, sorry, how do those two segments form a 90-degree angle? What would we know about them? Okay, they come into the same spot. Their slopes would have to be what? Right here, right? So this one and this one would have to be what? Opposite reciprocal, right? So to prove this and graphing, we can use the distance formula, right? Because we still have to prove that the sides are congruent to each other. And then we're going to use slope. What's my distance formula again?
Square root of the difference of x squared plus the difference of y squared.
Plus.
Difference of y squared.
Doesn't matter if the y's and the x's go in the same order. Why?
Because you're squaring.
Because I'm subtracting them and then squaring them. And then I'm going to add them at the beginning. So it doesn't matter even if I did the y's first, right? So again, remember when I said what's the generic formula? This is the generic formula for any 2 points, not just putting numbers in. A lot of people on the semester test put actual numbers in there. It was really confusing. I didn't understand where you're getting the numbers. Okay? So then if we're talking about slope, obviously we can do a couple of different things, right? We could do finding the slope from any 2 points, or we could actually graph it and then figure it out. But if I'm going to do it from any 2 points, my slope is what? And what's the most important part of this? Now I gotta have subscripts, right? Because the 1s and the 2s have to be on top of each other. And again, they're subscripts, not exponents. But then, to prove that it's a rectangle, we should have perpendicular slope.
So we need to have the opposite slope of the original.
Right. Opposite and what?
Reciprocal.
Right. So perpendicular slope is going to be opposite and the reciprocal. What's it mean? What do those two things mean?
Flip it, flip the sign.
Flip it and change the sign. Exactly right. So you're going to go through here, and so if we would use Gabriel's drawing still, we would first say that this isn't a parallelogram because we know that this and this don't have the same slope. But we could still.
I disagree.
Okay. Okay. So properties of a rectangle. Let me get all this down. But this is on, I believe, 423. If you want another reference in your book. But these are essentially what we're talking about right here. Okay. So if you want to write all these down again, these are all things that we've talked about in the last couple days. Whether it's a parallelogram or whether it's, is it on there? Yeah.
Yeah.
Or whether it's a rectangle. So now this is the culmination of everything that we've talked about, right? If it's a rectangle, the opposite sides have to be congruent and parallel, right? That's a parallelogram. Opposite angles have to be congruent. If one's 90 degrees, they all have to be 90 degrees. Consecutive angles are supplementary. Consecutive means either up and down or left and right. And then diagonals now are congruent and bisect each other. So they have to do both. And then finally all 4 right angles. So again, there's a really good chart, like I said, I believe on page 423, or you can write them yourself, that doesn't matter. If you don't like to write a lot of stuff down, then just put in page 423 in big print so you know where to go. Hey, Raman, or erase your finger digger here.
Oh yeah, you know, right? That's all I need.
I don't remember anybody saying that.
I did.
What?
I didn't.
I don't think so.
Everybody got it written down? What you want? Alright, here we go. Make sure again you read the directions, right? The directions are the most important thing because it's going to tell you what it is. Alright, so in this one it says a rectangular garden. I cannot argue even if you don't think that looks like a rectangle because they call it a rectangle. Except for Jackson's theory of, oh, I just put slashes on so the sides are automatically congruent.
Well, that's what you taught us.
No.
You
Okay. A rectangular garden is reinforced with diagonal braces to prevent it from sagging. If JK is 12 and LN is 6.5, can I find KM? Let everybody think for a second. Can I find it?
Yes.
Why?
Because those two diagonals are congruent to each other.
So they're are congruent to each other, right? So, what's my answer?
13.
Everybody agree? Okay, so how could I go about this? Let's say they take this diagonal out. This one right here. Okay? And so we're looking at this triangle right here. And they told me that I had this side right here and I had this side right here. Can I find JL? Why? The Pythagorean theorem, right? Because anytime that I form a what? A right triangle, I can use Pythagorean theorem. What's Pythagorean theorem again? And what does C have to be? Which is always opposite of the right angle or the longest side. Okay? So keep that in mind. Now, we're back into right triangles. We'll use that a lot. I think pretty much the same thing. So this one's pretty much the same thing, but now we're just using quantities instead. So quadrilateral RSTU is a rectangle. Again, I can't argue it, but now, boom, all those things have to click into my head. What's a rectangle? Or what are the characteristics of a rectangle? If the measure of RTU, okay, so be careful and know where we're looking. When they say RTU, we're looking what?
The bottom side of A and C.
Right up in there, right?
Yeah.
Okay? If that's 8x plus 4 and SUR, okay, everybody see where SUR is 3x minus 2. Can I find x?
Yeah.
Yes.
Why?
No.
Or
No.
equal to each other?
No.
Okay.
Why equal to each other?
Just like,
So it's right there and right there, right?
Yes, sir?
Yeah.
Okay. He scratches his. Put him equal to each other. Now, so, would you agree with this? Does this angle which they give me, is that the same thing as this angle right here?
Yeah, pretty equal
You don't
to
know.
90.
Get it in a box.
What?
Yes.
Are you
last year.
kind of just guessing, or is that a confident yes? Okay. So, it is a rectangle, so I automatically, so even though that they didn't put a box, which is a great point, because they tell me it's a rectangle, then that has to be one of the criteria, right? That all four of them are the right thing. So, is this little u down here, the little part of u, this one right here, the same thing as this right here?
Yes.
And is this right here the same as this right here?
Yes.
So these two would add up to what?
90.
360.
No!
90.
What's the right angle? 90, right? So basically I'm taking this and replacing it up there because look at this triangle and this triangle right here are the same thing, right? So form the isosceles. So I'm going to take those two quantities and set it equal to
90.
90 degrees.
So, do the diagonals always like bisect the angle then?
No, it has nothing to do with bisecting the angle.
Well then how,
Because I just know that, see basically I could take this triangle right here
yeah.
and flip it over on P and stick it on top of this one right here and they would match up
Oh, I
perfectly.
see now.
So then this angle right here and this angle right here have to be the same thing.
Yeah.
And then I could do the same thing with the two side ones.
Because they're isosceles.
Right. Because that's what we were trying to show in this right here, right? Forming those two sets of isosceles. So they have to equal up to 90 degrees. Everybody good with that now? Okay? So I'm going to take 8x plus 4 plus 3x minus 2 is equal to 90 and solve for x. Now again, this one only says find x. If it says find a certain angle, then I have to take that x and put it into one of those quantities. Right? So make sure you answer the question. Need to see the math. Okay with that? Pretty much the same thing. Let's think about this one. I like to show this one because you basically just have to read it and understand. So some artists stretch their own canvas over wooden frames. This allows them to customize the size of the canvas. In order to ensure that the frame is rectangular, before stretching the canvas, an artist measures the sides and the diagonals. If AB is 12, everybody see where that is? So if the top's 12, BC, which would be the right-hand side, is 35, CD is 12, and DA is 35, BD is 37, and AC is 37. Do I have a rectangle?
Yes.
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 Everybody agree?
Yes.
So we started hitting those criteria, right? The top and the bottom was one set of opposite congruent sides. BC and AD were opposite congruent sides. And then my diagonals were equal, so as if we hit all those, then we have a rectangle. If one of those didn't match up, then we would say no, it just doesn't work. So this is the one that we're talking about. Quadrilateral JKLM has vertices of And then they give it to them, determine whether JKLM is a rectangle using the distance formula. Now they specifically ask you to use the distance formula in this one. I really don't care what you use.
Did you do the thing where you go like
Yep.
over?
So as long as you can show that we have the right things, then I don't care what you actually use. I'm not gonna make you zero in on one or the other. Okay, so if you're gonna do the distance formula, you can go through and you can do all this. But as Aiden just got done saying, I'm gonna basically, I don't even really care what the answer is, right? I just wanna know that it's true, meaning that they're equal. So if I draw this triangle right here, and then I draw this triangle right here, basically I'm asking myself, are those hypotenuses the same thing, right? Okay, so did I go across 2 and across 2? Yes. Did I go down 1, 2, 3, 4, 5, 6 and go up 6? 1, 2, 3, 4, 5, 6. So are those blue hypotenuses have to be the same thing?
Yes.
They have to be, right? So again, now that's using the distance formula, and then we can also do the slope, right? So if we switch it up a little bit and do the slope now, I'm looking at what is the slope of this shorter side. So how do I find my slope? The rise over the run, right? Up 1 and over what? 3. So my other slope, meaning this long side, would have to be what?
Yeah, so
Which is
negative 3.
-3 over 1, or -3, right? So let's check it out. Down 1, 2, 3, 4, 5, 6, and over 2. Would that make my -3?
Yeah.
So we proved that this point right here is perpendicular, and we have a group of congruent sides. Should tell us that it's a what? It is a rectangle. Is it a parallelogram?
Yes.
It is a parallelogram, and is it a quadrilateral?
Yes.
It is, right? That makes sense to everything?
Yes.
Okay? So again, you just have to be able to prove it, and otherwise you would have to just do the distance formula again here and here, but we're going to draw that same triangle in a sense anyway. So that one would have been 1 by 3, and 1 by 3 tells us that they're the same.
If you were gonna use a distance, does it matter which points you use?
In a sense, yes, you can't use diagonal ones. Well, actually you could. Because you could do the distance formula from here to here and here to here and prove that. Right? Because if the diagonals are congruent, then I know that it's a rectangle. So absolutely. Great thinking, Gabriel. You're on the ball. Alright, questions? Okay? So, the biggest thing that makes a rectangle is what? All of the other things, but then we zero in on the diagonals again. Okay? Then we zero in on the diagonals. So, this assignment honestly won't be due until, what's tomorrow?
Thursday, Friday.
So, honestly, it won't be due until Monday. Right? So, yesterday's assignment that you got from Mr. Fox will be due tomorrow. And again, you got some time. If you're struggling with 23 or 22, do those right now so I can help you out. No, I think just 20 is. Just 20 is 6 points. I think that might be approved. So just number 20 is 6 points. 14 through 19 are just 1 each.
So,
Jack's where you hit that to stop it.